Hello, in this video we will learn about molar ratios and how they are used in chemistry. First, we will look at ratios in mathematics, then balanced chemical equations. We will apply what we have learned to solve molar ratio problems as they are used in chemistry. In chemistry, more complex stoichiometry problems will use the mole ratio step. This is performed normally in the middle of the calculation. Finally, we will practice some mole ratio problems. Ratios in mathematics. Apples and bananas are in a fruit bowl in the ratio of 2 to 3. How many apples are there if the bowl contains 15 bananas? So to solve this problem, first I would write that apples are in a ratio with bananas. I'm going to simplify that to A to B. The double dot here means ratio. From our question, we can see that the apples are in a ratio with bananas at 2 to 3. However, I do not have 3 bananas, I have 15. So apples, my unknown, would now be in a ratio with 15. I need to find a link between the 3 bananas and the 15 bananas. So 15 divided by 3 is 5, or 3 times 5 is 15. So the relationship here is 5. I need to apply that same relationship to apples. So 2 times 5 is 10, or 10 divided by 5 is 2. So that means there are 10 apples in the fruit bowl. Balanced chemical equations. During a chemical reaction, atoms will rearrange and new substances are made. It's important to note that atoms are not created or destroyed during a chemical reaction. And to ensure that we show this, we will use balanced chemical equations. So balanced chemical equations will have the same number of each type of atom present on each side of the equation. So to balance a chemical equation, we use coefficients. Coefficients are numbers that go in front of the chemical symbols in that equation. So in this example here, I have Mg magnesium combining with HCl, that's hydrochloric acid, making MgCl2, that's magnesium chloride, and H2, that's hydrogen gas. So in chemistry, it's probably important to note that the absence of a number means 1. So this magnesium has no number, that means there's 1 of them. HCl, there's no numbers, that means there's 1 hydrogen and 1 chlorine. But over here, I've got Mg and a Cl2. This little 2 means there's 2 of what comes before it. There's 2 chlorines. And this little 2 means there's 2 hydrogens. To balance this equation, we're going to use coefficients. Now, coefficients go in front. So we could put a number in front of the magnesium. Currently, there's no number, so there's 1. We could put a number here, or a number here. So let's check and see if this equation is balanced. So Mg, currently there is no number, so there's 1. And over here, Mg, no number, so there's 1. So that works fine. But this HCl, there's 1 of each. There's 1 hydrogen and 1 chlorine. But on the other side, I've got 2 chlorines and I've got 2 hydrogens. So this equation is not balanced. So to balance it, I need a coefficient. I'm going to place that coefficient in front of the HCl. So what this means now is instead of having 1 HCl, I have 2 of them. And that means I'm going to double both the hydrogen and the chlorine atoms. So as a result, 2 hydrogens and 2 chlorines, which balances out the 2 chlorines here and the 2 hydrogens here. As a result, we now have a balanced chemical equation. Molar ratios in chemistry. Balanced chemical reactions can be used to determine molar ratios in chemistry. So what we can do is take what we've learnt from balanced chemical equations and what we've learnt from mathematics and ratios and put them together to solve a ratio problem in chemistry. So our sample question, how many moles of magnesium is required to completely react 7 moles of hydrochloric acid? So first of all, I need a balanced chemical equation for the reaction between magnesium and hydrochloric acid, which we learnt on the previous slide. So note there is the 2 that we got to balance that reaction out. We're going to need that number. So the question refers to magnesium and hydrochloric acid. So my ratio here is magnesium to hydrochloric acid. And if I simplify that down, it becomes Mg to HCl. And the ratio that is relevant here is from the balanced chemical equation. So the imaginary 1 here and the 2 gives me my ratio of 1 to 2. So the coefficients determine the ratio. Our question lets us know that we're not interested in 2 moles of hydrochloric acid. We're interested in 7. So my new ratio becomes magnesium to 7. And as we've done before, I need to now find the relationship between the 2 and the 7. So 7 divided by 2 is 3.5, or 3.5 times 2 is 7. So the linking number, the relationship here is 3.5. I apply that same ratio to the other side. So magnesium becomes 3.5 times 1 is 3.5. So that means I will need 3.5 moles of magnesium to completely react with 7 moles of hydrochloric acid. All right, so it's your turn now. So I have a new chemical equation this time that I've balanced for you. It's a bit more complex than the last one. So we've got 2 moles of Fe2O3, 2 moles of Fe2O3, so that's iron oxide, combining with 3 moles of carbon to make us 4 moles of iron and 3 moles of carbon dioxide. So your job is to do some calculations as we've learnt just previously. So question 1, how many moles of carbon is required to completely react with 6 moles of iron oxide? Number 2, how many moles of carbon dioxide will be formed from 8 moles of iron oxide? And number 3, what is the number of moles of iron produced when 18 moles of carbon dioxide is produced? So I recommend that you press pause before I put the answers up. So press pause on this video, do some calculations, and when you're ready, you can start it again, and you will find that the answers to those 3 questions are 9 moles of carbon, 12 moles of carbon dioxide, and 24 moles of iron. I hope this video has been helpful, and thanks for listening.